Cool. So my name is David Caudill. I work at Capital One on our SRE enablement team. And having worked on teams like this for many years, I've spent a lot of time helping people make sense of their metrics and data. And I'm looking forward to talking to you about it a little bit. So since I work in a highly regulated industry, I first want to tell you that this talk is comprised of my personal opinions and research and does not represent the point of view or positions of my employer, nor my experiences with my employer, because who of us is here to talk about anything that's happened with our employer? Cool, so here's where we're going today. First, I'm going to make you listen to a slide about me because I have a microphone. Then we're going to talk about the problem that's kind of the core of this talk today. Talk about some tempting but ultimately bad ideas or potential solutions to this. Some ideas and solutions I think may actually work for it, and we'll wrap up with a little bit of what I hope is practical advice for how you can evaluate sort of where you're at in that particular journey. So a little bit about me. I've done a lot of things, really random things. Kind of done everything in tech at this point, so I have a super generalist sort of point of view. What that means is that I'm not a deep expert in every single thing that's going to be in this talk, and I'll do my best to tell you when I'm out of my depth a little bit. But in general, that breadth gives me a good view of sort of systemic issues like this. And really the most important thing to know from this slide, I have two pugs. One of them is Gumbo and one of them is Frink. Really the most important thing from this talk, just look at them. So here's the problems that we're here to talk about. A lot of this is going to feel really familiar to you, and I think is rarely said. One of the biggest ones kind of out front is the loudest voices in the room about observability, or sort of what makes good observability, are people selling observability solutions. Which, I think if I told you about almost any other industry, you would look at skeptically. But we've kind of come to accept. And I guess as a byline of that, go give a conference talk. Especially if you're not a vendor, come do a conference talk. That doesn't have to be that way. We have really unrealistic expectations for what all this stuff can do for us. I think that we could describe these systems so clearly with our observability solutions that with no understanding, you could come to understand an application by looking at those signals. And that's not how any of this works. We have really low quality data and we have way too much of it. Architectural complexity has bitten us with this, just like it's bitten us with literally every other thing, even including org structure. Architectural complexity really weighs on this a lot. The cost of this stuff is astronomical. If you're running your own, the labor costs of it are often astronomical. If you're buying from a vendor, the dollar costs are astronomical. This is a really expensive activity that we do as organizations. And I think it's rarely looked at with a skeptical eye. And also the cognitive load of many of these solutions is just not even thought about or approached. And many of these systems, as we'll talk about more, exceed your ability to process them by multiples. And you feel smart because of it, but it's not helping you. So on that expectations front, for many years now, we've talked about monitor everything as our maxim. And so what we've said is throw all the data into the data junk drawer and sort it out later. So that means for all of us here, almost regardless of size, you're into millions and billions of logs and events, of traces, of metrics, on everything, and really on the off chance that you might need them. You expect that you can retrieve all that stuff instantly and error-free. You want to use this data to solve real-world problems, but you don't want to provide any training on the tools or documentation on the metrics that you've put into these systems. And you want to have all this data available even if there's an outage of your cloud provider. Which of course means right off the bat here, either you're doubling that data or your vendor's doubling that data. And perhaps most importantly here, you want to do all this for much less than it actually costs. Sounds like a plan. So on the data front, like I said, you got a lot of this stuff, and it's mostly junk. It's junk because it's all highly contextual and it's almost always out of context. You probably have no utilization information on that data itself, so you don't know who's actually looking at what. And if you do have that information, you probably don't look at that yourself. Of course, some of this data is really useful and really valuable. Otherwise, this would be a really short talk. Delete. Right? But it's not. Some of this stuff is absolutely necessary to operate your service. But it's often also just really hard to browse or to play in this data to get a sense of like which of these, for example, which of these tags contains the most values, which of these is the most likely to be populated, which metric is the busiest, etc. It's often not easy to explore or sort of pivot or manipulate this data. It's often really static, and it's done that way, of course, to optimize for very narrow situations like Prometheus with time series metrics or whatever. That makes those products viable as engineering solutions, but it also makes them really hard to use as an exploration tool. On the architectural front, I mean, this is a slide we're probably all tired of seeing at this point. We made that switch from service-oriented architectures many moons ago into microservices as kind of a dominant architecture, serverless, everything. Every single step we've taken through this whole journey, and really the whole 15 years I've been in the field, has introduced new inter-process communication overhead. And every time we introduce that, of course, we now want to monitor that. So what might have been a method call 10 years ago now might be a call to a separate service, or to a function as a service thing that's running, inside of a platform, to containerized solutions that spew metrics. I can't think of any of those. But every single one of those calls, we want to instrument to forensic detail. So if we're going to run a serverless architecture, we're going to want to instrument our startup or teardown times. We pay money for that startup time. We pay money to store data about that startup time. The point being here, though, every single thing has really exploded in complexity during that time. And that, of course, has produced an explosion of monitoring or telemetry data. And the principle here is Ashby's law, if you're curious about it. We don't have time to go into it. Go look it up. I like old stuff in engineering. So on the price front, another slide or discussion you're probably sick of having at this point. The 2010s really were an era of really cheap money, and that flooded the market with irrationality. These vendors were the pickaxes for the gold mines that we were all sold, right? They made a ton of money. A lot of that money was heavily, heavily subsidized by venture capital, and with interest rates the way they are now, it is not easy to go get $100 million on a whim like it felt in 2018, for example. What that means is now your vendors, sometimes just like you, kind of need to start thinking about this making money part of business and less about, the generating hype or the selling of thing. And so what that means is something here is going to give. You're either going to store less of this stuff, it's going to be stored in lower resolution for less time, that kind of thing. But something has to give. And storing all this data is not even cost effective for your vendor, right? We mentioned that multi-cloud problem earlier. Your vendors, like most of these vendors, are storing data in multiple clouds. That is not a cheap proposition if any of you have taken on or have the misfortune to take on a multi-cloud project. We all want that, right? But unfortunately, for the most part, what that'll tell you for doubling the cost is that AWS is down. That's quite an expensive way to determine that. It might be more reliable than their status page. The status page jokes always go over great, don't they? So there's really no magic for anybody here in avoiding these massive cloud costs. Your vendor still has to pay money to run their software on somebody else's computer, no matter what. Now, they're going to get a volume discount that you probably can't get. That doesn't make any of this problem go away. But kind of the punchline here is that sooner or later, somebody in your finance team is going to come ask you what I think is a really good question that we should have asked a long time ago, and that's how can any of these tools possibly be worth what we are spending on them right now? We're also on the cognitive load front. This is fairly deep waters. We'll move through this as fast as we can and sort of hit the points here. This is old CogPsych. In general, cognitive load just describes how many things you can keep in your working memory at a time. That's been established since the 50s that's 7 plus or minus 2 items. Now, what an item is in that memory is pretty wishy-washy, right? You can think of it as a chunk. If you know a system really well, you can point to that system. It might be in your long-term memory, and all you're referencing there in your memory is a pointer to that. If you don't, if you're new to a system, the cognitive load is multiplied for you when you approach it, right? But in general, we're not thinking about any of this stuff at all. We're presenting people who can hold 7 plus or minus 2 items with 200 items and telling ourselves we're really smart because look at all the graphs. And if you'll notice here, the exit from working memory here is the trash can. And the point being, just you don't actually get to choose which of those items is squirted out the other side of that working memory when a new item is added. This is just how brains work. That's the rules of the game. And we don't care about the rules of the game. We just pretend they don't exist and either tell ourselves that something went wrong, and blah, but like, that's just how our brain is. Don't feel bad if that's where you're stuck. And unsurprisingly, all this stuff leads to cognitive overload, right? Your capacity goes down. You'll note that was flexible there. That flexibility is not your smartness. That flexibility is the level of concentration you might have available for a task, right? So all kinds of things contribute to reducing that. Executives on incident calls, deduct a point. Sorry, executives. They do make every incident worse. That line always goes over well too. All of us have got this mountain of poorly named dashboards. You get on an incident call and you discover that like, uh-oh, MongoDB is in a bad way, and you go look at your list of dashboards and discover there's 300 dashboards named MongoDB dashboard. Some of them are more important than others, right? But where you'll find them is probably called something like George's MongoDB dashboard, right? That's not much of a plan. But we knew going into that, we would need to know what was important about MongoDB. We just never had the conversation because there was going to be disagreement. And who wants to have that, nerd sniping disagreement? Just let's sort it all out. But the cost of this, of course, all this debris, all this extra data laying around. And not to mention the mountain of metrics, the decay of our namespaces as we get more people involved in these systems, which is a thing that we really wanted, right? We all pushed, hey, everybody jump in, start posting custom metrics. And after that, we realized that we should have had a naming convention. All this stuff really piles up and adds up to cognitive overload. And I guess my point here is just, again, we don't care. We're not thinking about that. We're real smart engineers here, so we don't have to think about this limits of our intelligence kind of stuff. That's for less smart people. That's for people who went to school for what I went to school for. Not for us. I went for electrical engineering or whatever, right? No, everybody's brain works this way. We just pretend it doesn't in engineering. So let's talk about some dead ends and well-worn paths to nowhere here that I think are very tempting, but ultimately stupid. Number one, you already have a lot more data than you know what to do with. But because all we have said for 10 years is monitor everything, your first instinct in response to this is going to be to go figure out what is the data that I don't have that could actually solve that problem. Stop doing that. You already have the data. That's not the answer. Obviously, the same vendors that got you into this mess are going to sell you solutions for getting out of it. That's good. Nobody wants you to have a bad experience with their product, right? The trouble is all the solutions are going to suffer from the same problems, right? They're going to sell to you rather than think about your needs in a practical way. And selling to you always involves appealing to your ego, which always means overestimating your intelligence to you as a way to tell you how smart they think you are so that you buy the thing. AI and ML solutions here really seem to be designed just with expending maximum carbon to generate spurious correlations in mind, right? All of us have had, cool AI tools that have told us like, hey, your database connections are like way down, and looked and discovered that, my front end is down. Thank you for that insight. That's anomalous, yes, but that's not news. It's not helpful to me. AI is really not going to save you from this, and it's also not going to stay cheap, right? Because it's at that hype cycle that we talked about earlier. It's the pickaxe that's being sold today for the gold rush. The same thing's going to happen here. We're in the rot cycle with it in 10 years. Just watch. But it's not going to save you from this, because ultimately nobody and nothing can understand your system for you. You have to do the work of that. And if you have a mental model of how your system works, you can use that telemetry or that data to explain it to you or help make that make sense. But if you don't have that model, the data is not going to make that evident to you. So what do we do about this? Given all the external shifts and all the macro context here, we bled something like 250,000 tech jobs in 2023. I think we're probably on track for the same thing now. All of us are going to be squeezed. That is just a given in tech, except for some real rare exceptions, AI. We're all going to get squeezed. And so we're all going to have to make hard decisions, I think, in the coming years here. And we're going to want to do all this, reduce all these costs, reduce the labor expenditure, reduce the infrastructure expenditure for these solutions without losing what's important, which we don't know, without getting worse outcomes from our incidents, and with really only limited advice from our vendors because of that obvious conflict of interest. And so the only real solution here, in my opinion, is to do the work of making sure people in your organization actually know what any of this means or how any of their stuff works. So let's talk about the hard work of constructing meaning. And I've chosen these words really deliberately, and we're going to unpack that language a little bit here. So in this context, what I mean by meaning is that your team understands what the consequences are of a metric or an alert. So when they see that this metric is bad, they know this is what the customer experience is probably like. People who are attempting to purchase a movie ticket are not able to do so right now. It's not hard to attribute an emotion or anything else to that, right? You want to see your team change their behavior in response to this data, not just build an understanding, which is a hard thing to know they're actually doing. You want to see them put that into context with the other metrics, understand how these metrics fit together, which if you can think of, say, MySQL is a great example. There are many metrics there that fit together that you can understand when this one moves, that one moves, or whatever. Because we've all worked with MySQL a long time, some of that stuff is fairly evident to us at this time. You should know that about your own applications as well. I'll almost guarantee most of our dev teams don't. You want to see your teams use this data to identify problems, but you also want to see them use this data to verify that a problem is no longer present. But there's a big catch-22 here. And if you remember, we talked about how lame all this data was, or how bad the situation is there. You can't expect anybody to build meaning from this data because it's a big mess. But if they don't ever engage with that big mess, they're not going to make it more meaningful. So we're stuck in a tailspin there, where nobody really wants to jump in and look at this because it's just noisy and gross. But it can't get less noisy and gross unless somebody jumps in. And in terms of construction, or what I mean by constructed here, you can't just tell people something, right? People have to engage with or play with something in order to make sense of it. You have to do that telling, obviously, but that has to be coupled with an experience that helps them connect what you're telling them to the reality that they have, or the stuff that they do know. So there has to be a bridge between that stuff and what they do know or what they are sure about. Really, the bridge there is play, again. You have to go play with this stuff. You have to go learn, say, the query language or whatever else, and just flip it around and see what it looks like. In the same way that if you handed, a little kid something, they would see how it fit together, whatever else. This is all the same thing. And this is constructivism. If you're interested in this, people like Piaget, Vygotsky, Montessori all talked about this stuff. Again, really old knowledge, but really applicable here. And our goal, or our hope as observability teams, as SRE teams, is to make that learning as easy as possible, or to facilitate that in some way. And one of the ways I recommend that you do that is to work backwards from a vision. So think a little bit like a product manager. Think through these scenarios and the personas that'll be engaged with this stuff. Here's a few that I put down. You've probably got more unique ones, but incident response is an obvious scenario. Performance degradation is a big, nasty scenario that is extremely common, probably more common than hard down situations are anymore. And then high-level status communication is another really common scenario that you would need a dashboard for. Let's talk about some strategies for fighting that cognitive overload that we talked about earlier. I have some quick tools, or quick tips here for tools. Think about designing dashboards for, in this case, I've chosen a new developer with a migraine. In general, just don't think about you on your best day and how smart you feel on a Friday afternoon and you got a spare minute to write a dashboard that describes that cluster or whatever. Think about you when you woke up at 2 a.m. and you're angry. What is the information you need at that time? How would you process it at that time? What's the least I can provide here, because I don't want to overwhelm that person who's probably in a bad state because they got paged into an incident bridge with 200 people on it and there's an executive on there. Do take advantage of all the note widgets or markdown widgets that your solutions provide. So if you have a way inline to provide documentation that says, here's information about that custom metric and what it means, or here's the lines in code where this is fired or whatever else, use that thing. Use that as a way to build a bridge into your documentation from the notes. And again, this is that context thing. Try to group similar items together. As simple as that sounds, that's probably not happening in every case. If you've got a nice little visual container sort of block in your tooling, use it. Try to decide with your teams on a few really important dashboards. It's good that everybody in your team has constructed their own understanding of this. That is necessary for them to process it. But there needs to be a place where you come together and you say, if this dashboard looks like this, we have a problem. And maybe that's not everything. Maybe there's one guy on the team who's like, no, definitely socket exhaustion is the biggest problem we have with it, I swear, and everybody else says, we don't know what you're talking about, whatever. That's fine, put that over here. Here's the stuff we agree on, and everybody knows it, right? It's starred, it's marked, it's bookmarked, whatever in our tool. These are the important dashboards for that. And you're gonna have to put somebody in charge of doing this stuff. It's not gonna happen by itself. It's not gonna happen because you told people to do it. As a former manager, I know if you don't put a ticket behind it, if you don't allocate labor to this, if you don't describe the project or your goals, it will not happen. So well-intentioned speech, yay, no, that's not enough. One quick mention at the end of a meeting, again, not enough. This is work. So some stuff you shouldn't do. If you have a status dashboard, don't put any information in there that does not absolutely need to be in there. Don't build a new dashboard every single time you want to know something, or if you do that, tear it down on your way out the door. leaving a mess here is just more noise for when somebody comes in the middle of the night to figure out which of the MongoDB dashboards to look at. Again, same sort of principle, building dashboards in response to incidents. Some of this is a good behavior if you really believe that incident is going to happen. For the most part, as an industry, we've gotten really good at this post-mortem stuff. So that incident you just had is probably the least likely incident to happen now. Maybe you don't need to add a dashboard explicitly for that. That problem has been solved. That's not necessarily where you need to go next. And a big one here that feels unrelated but is extremely related is stop breaking Conway's law. If your engineering orgs are designed so poorly that many applications, even metrics, are split across team boundaries, and it's unclear when this boundary is bad, who do I actually talk, or when this metric is bad, who do I actually talk to? You have multiplied the complexity of every single incident. You've multiplied the complexity of every single troubleshooting session. Everything is worse because you have done that. If you have done this, if you're managing your engineering org this way, stop. So nobody's doing that, right? No, you know. So separate your status information from your diagnostic information. This is a really important one. It's a really simple one for you to implement. Status information is just, like Alex showed on that nuclear control panel or whatever, how are things right now? Not how have they been going today, not when was the last time a message about this fired or whatever else. How is it right now? Is it red, yellow, or green? And that's it. This is your check engine light, right? None of us wants to be driving our car and see the actual OBD2 code show up and try to think, oh, which one is that? I think it's my EGR valve and my head gasket is going to explode. I should pull over. None of us is that smart. Shut up. You're just not. You just need to know, get the car off the road, bad things are there. And then, while it's off and not likely to catch fire, you will investigate that. And that's diagnostic information at that point, right? So your goal with the design of these things is to take that simple status information, that highest level red, yellow, green information, and guide people to diagnostic information, but the minimum diagnostic information that they need in order to approach a given system. So if you have a system that is a front end, middle tier, back end, that's 3 divs, red, yellow, or green, as your entry point, so that everybody is not looking at erroneous information about 7 different very specific things, or time series, or whatever else. They're just looking at those 3, and that's where they begin. So if they see the red div is in that middle tier, they engage with the diagnostic information about the middle tier, not all the other edges or whatever else. Some of this is easier said than done, right? Because that's a great example. There's a causal relationship between those 2 things. How do you actually make them show up? You'll have to think about that. You have to do some work. I don't know your app. I don't have a solution to that. So you should also start with what's important, not what's easy. I think a lot of us here who've been in the field a while can remember when we made that big leap in observability many years ago to these newer solutions. We can remember doing things like updating a config somewhere and suddenly lighting up like 10,000 metrics and saying like, yes, look at this. That's amazing. I know so much about this. You don't. You have a lot of metrics. But that turnkey stuff is really tempting, right? It looks like progress. It is not progress unless you know what the application does and what the most important thing about it is, and you know you've got that covered. Everything else is really not as important as that. So even if it's changing the lines in the YAML file, stop doing that stuff and go focus on what's actually important about the application and make sure you have solved that as well as you possibly can. And in simplest terms, this does mean stuff like if you're an e-commerce site and people are adding things to the cart, what is the success rate of adding things to the cart? Not making an API call to the 7 APIs that you have in your bad microservice architecture to add things to a cart. What's it like to add a thing to a cart? If you can't know that, the rest of the stuff is noise. It's too hard to debug. You've made a mess. Similarly, don't confuse rolling out new tooling with constructing anything meaningful here or with solving an actual problem. So some real simple examples you can think of here is, like I mentioned, that checkout button. What's the error rate on it? How long does it take to check out? How many people are checking out right now? Basic stuff like that. You need to know this stuff if your application's job is to check out. Similarly, when you get an error at this endpoint, what's the customer impact? What does it mean? If you can't answer these, you have wasted your time with a lot of other solutions, a lot of other noise. And we all have. Don't feel bad if that's you. It's you. So on that cost front, this is a particular nasty one, and I'd imagine if you're using a commercial or off-the-shelf solution for this, this is on your mind as well. These building schemes are cryptic and complex. I would say they're adversarially designed if I were not such a nice guy. But there's no free lunch here, right? Early on in this process, a lot of us found a way to like, I don't know, maybe I can squish tracing into the logs, or I can squish logs into the events, or whatever else. And our vendors said, oh God, why are there 10 million events right now? And fixed that, so now that's expensive too, right? So you're not gonna find a trick in the billing scheme. If there's a loophole, it's just waiting to be closed. The best way to really make sense of all this is to think about the value of what you're storing versus its cost. That's fuzzy math, but it's not that fuzzy for you. Take a look at your detailed bill and understand where the cost is coming from. Talk to your engineers, understand where the value is coming from, and ask yourself why those don't look that much alike very often. Also keep in mind, having sold a lot of SaaS myself, special billing deals have a way of becoming normal billing deals overnight. So it is the SaaS playbook to sell you a solution for much less than that solution actually costs, get you heavily locked into that, and then when it becomes the normal billing scheme, then you discover how expensive the choices were that you made. That's a bad time to learn this cryptic billing scheme. The best thing for you to do from the outset, special deal or not, is behave as if you are under normal billing. And I say this because a lot of us are going to, in response to these bills, switch vendors and repeat exactly the same cycle that we just went through with the last vendor and be surprised at that. You should also, spend time on the bill, look at the bill, invest engineering hours in looking at the bill and understanding that. It's very tempting as a manager to do this. I think as a manager you should do this. Your engineer should also be actively involved with this. Again, this needs to be spec'd out, this needs to be project work, and it will pay for itself if your bills are anything like my bills have been in the past. Ultimately, you're going to have to spend less and retain less. Or it's like send less data and retain it less often. Nobody wants to hear that, right? Especially coming off of this monitor everything high. But this stuff's too expensive. And it's too expensive for a number of reasons. So let's talk about OTel here also as a potential cost mitigator. OTel is a complex project, and this has potential to spiral into labor costs as well. But if you're in a place where you have a solid understanding of this stuff, you can use an OTel collector effectively as a middleman to strip off things like bad choices you've made about how you send data. Say one of your data devs, hypothetically, this has never happened to me, decides to add a GUID to a tag. And you discover that your bill is looking a lot like 10 times what it was before because they did that. And also, there's a lot of priorities. They can't change that right now, sorry. With OTel and stuff like that, you can just discard that and then have the fight while you're not bleeding cash. Also, question your assumptions that you have about this stuff and how you got into this mess in the first place. All these assumptions really, for the most part, come from our own egos. A lot of us believe that we have extreme scale and do not have extreme scale, but are looking at conference talks from people with extreme scale and saying, yes, we've got to do that. You should ask yourself whether or not you're really using everything that you've got. I can't tell you how many implementations of stuff like tracing I have looked at that were awesome and nobody used them. Sometimes you should just stop. If you're not getting value out of it, don't. Or make sure you go get value out of it. But stop assuming that because you put Zipkin into production, people are using Zipkin. If they know how to use it, but they might not. Or they might not like it. It might be broken for reasons they don't want to explain to you or wouldn't bother with. And it's just sitting there spending EC2 or something like that. A great question to ask yourself is, if we didn't know this, would we do anything different? Not would we understand, not philosophically or whatever else. Would we do anything different? Would we behave differently? Similarly, you should ask yourself, all that convenience stuff that we talked about earlier with the expectations, do I actually need it that convenient? Is there a way I can put this in slower storage? Can I put this in S3 and query this with Athena? Because only every once in a while do I actually need an audit log for things. Maybe not everything needs to be the hottest, fastest, most available solution for that, or kept for as long as you think. Some of it maybe can retire to colder storage on the off chance that you need it later, that sort of thing. But the biggest thing to ask yourself here is just, am I blind to this assumption? Am I in denial because all these assumptions pad my ego? I feel smarter when I web scale than I do when I have 30 customers. Some of us in this room right now are in that place. So how do you know if this stuff is getting any better? Let's say you watched this talk, you took my sage, experienced advice, you have no idea if it did anything for you. So before we get started here, I'm going to talk a little bit about qualitative evaluation, because quantitative is so desperately popular right now. There is a popular adage in management that if you can't measure it, you can't manage it. And that is an unfortunate omission of the important part of that sentence, which was originally that it's wrong to suppose that if you can't measure it, you can't manage it. A costly myth. That's exactly the situation we're in right now. There's a lot of the stuff that's obvious that you can't put a metric behind, but nobody has a freaking clue what any of this stuff means, and it costs you 20% of your cloud bill. Go with your gut on that one. Just because you can't quantify how much people don't understand doesn't mean that you're losing 20% of your cloud bill for nothing. So a great way to approach this is to ask questions and ask a lot of questions to a lot of people. Simple questions here are stuff like, I noticed you have an alert set on CPU in 2024. What's that mean for customers if the CPU is high? Now, obviously, that's just disingenuous because that's dumb in 99% of cases, but people still do it. You might also be surprised there, and it's actually really smart, and you didn't understand that. Similarly, I noticed these two things are next to each other in your team's dashboard. What do they have to do with each other? Maybe something, maybe not. Maybe I just happened to make this dashboard and I forgot I left that one on there. That would not be the first time I'd had that conversation. And the biggest question that you need to be asking every day, all the time to the teams that you work with, what is the most important thing to monitor about this application? Not all of them, not the list, not everything. What is the most important thing? So that you know the most basic thing is covered. A lot of us have moved into moon missions with distributed tracing and do not have the simplest case basic thing covered. Don't assume that. Also, ask a lot of people, compare their answers. You should evaluate the behaviors that you see, and postmortems are a real goldmine for this. What you want to see is that during an incident, data was used to make a decision. Do we fail over? Well, here's the data that I have that suggests we should do it or we shouldn't. Not because you've definitely always got that data, or that data may or may not exist. It probably does exist. What this really answers for you to that question is, what's the fluency of my teams with that data? They could quickly query an ad hoc thing and make a determination based on that. You also want to see that at the end of an incident or when an incident is declared closed, somebody used data to validate that assumption. Like, yep, we're definitely good because here is the data that I found that proves it. This is not a data-driven culture kind of thing. This is I can find the metric that relates to that because I know how to use the metrics database thing. Engineers are data-driven. You don't have to talk to us like we're salespeople. No offense, salespeople. So in terms of anti-patterns, these are going to feel really familiar to you, maybe funny. My favorite is, I tried this myself, and it seems like it's working. I have heard this on calls, not with my current employer, but with prior ones that were quite large names that may run some of the operating systems in the room. That's ridiculous. A lot of us are spending 20% of our cloud bill on having conversations like this on an incident call. Similarly, declaring an incident because somebody really important has used it and it didn't work. It makes you wonder, should we be spending this money or should we just ask that person just kind of like, can you just keep buying movie tickets on your phone all day? Because I think this is cheaper than the 20% of my cloud bill. CFOs don't like that, for the record. But you should be able to shut these things down really quickly, right? Because you've got all this money, you've got all this data, you've monitored everything. It's not working right now. It's working for 10% of people, and you on the incident bridge are one of the 10%. Congratulations. This is not over. That should be really easy to do, and this still happens. It also happens because we really want the incident to be over because we're tired. And same on the executive thing. You should be able to have a comfortable conversation with your executive of, you're holding it wrong. This is working for everybody else. Again, popular conversation, but really should be easy to have, right? You spend all this money. Also take a look at your bill. Is the thing continuing to sort of stumble higher? Is it higher every month for some reason? Do you understand why it's higher every month? Do you understand why you need another headcount in your observability team? Et cetera. Like, what are the things that are driving this? Are you still having these accidents where somebody does a dumb thing and tips over your cluster for Prometheus or multiplies your bill because they did a dumb thing or whatever? Or are you kind of past that, it's ignored? That value and cost thing, do you think that's getting more aligned or less aligned? Do you understand what's in the bill? And do the people doing these expensive things, are they aware that they did it? Do you have a smooth way to let them know? And are they, now that they're aware, not doing that anymore? But they understand why it was expensive? Anyways, that's my talk. Thanks for coming.
Thank you. We're coming up on break, but I do want to give an opportunity for if there's one or two questions, we can handle these now. I've got one right here, I see.
Right. So value versus cost and doing what's important. I have lots of folks that want to tag every metric with the customer and their account. How do I help folks understand that's not always important for every single piece of telemetry?
How do I help my users, I guess, pick the right data for their use case?
Yeah, I think that's really hard to answer without your context, right? But in general, you want to understand why they think that's that way really well, and whether or not you can meet that need in some other way that's less expensive to you, right? As the engineer and on point for this stuff, the hope is that you can translate that business need into something a little more cost effective. But that's a really hard problem. I've had exactly that same scenario with like large enterprise customers. You don't have a large customer list, but it's really important. You have an individual SLA with each of them. You have to know across each of them, that sort of thing. Sometimes though, if it is that important, it's worth paying for.
And then the one right behind you.
So we are all in the same place that we need to address on observability only the important stuff. How do you suggest cleaning up the metrics or whatever below the metrics? Because things are there since an incident in 2015, and who knows if there are millions of them.
So like, how do you clean up and standardize from old to new?
Yeah, that's a messy one. You guys have the best questions. These are better questions than SRE Econ. So that's really messy. It's tempting for me here to suggest an arbitrary migration as a way to wipe the slate clean for technical reasons and start over, if we were being slightly devious about it. Because the straightforward way of actually having all those value conversations about stuff feels untenable, right? Which is why these are great business models. Once you've got 4 million metrics in there, who wants to have 4 million conversations? None of us. It was very easy to get, it's a lot easier to get those metrics in than it is to get them out. Ultimately, though, that really has to come down to like auditing on a per team basis and like, taking that inventory of what matters. And then looking at that high dollar stuff and saying, this is the 80-20 stuff. 80% of this you didn't list as value. The 20%, like the 20% of the cost was the valuable part. But you really have to have that inventory, I think, to make any progress with it. But you have to start with what's valuable, not what's not. And a great way to look at this is, if you've ever watched the show Hoarders on A&E, where people have compulsive hoarding issues, right? Or the show Clean House, which is trash TV, with Niecy Nash. It was a great show. They had opposite approaches. Hoarders was real clinical, and they were like, can we throw this newspaper out? Are you sure? And Clean House would say, everything is going. Pick 5 things that you want, and we'll give you a pool table. And that was enough. But so you can't have a conversation in that way of like, is this one valuable? Nope. Is this one? No. Start with what is valuable, and by default, throw out.
Just give your engineers a pool table, and that solves it.
It may work.
All right, I'd love to do more questions, but I'd also love to get you all to break. So you can feel free to harass David in the lobby area while you're grabbing some coffee and some food. So another big round of applause for David. We will be back